Okay, I think yesterday I didn't quite finish number 2. Okay, we were just going through the solution here for question number 2. All right, so let's just have a quick look at that one. All right, we had first the basketball player was moving 0.75 meters to the right. So the key part of this is just picking a spot to represent the initial position of the basketball player. I'm just going to make it that red dot. Okay, and then I'm going to draw a line that's 0.75 meters to the right, and then from there, and this is the other key part of this question, from that point they go 3.5 meters to the left. Okay, so from here, okay, that is what they do. Okay, that is the kind of the full diagram of their motion. Okay, and again, yesterday we quickly talked about this. I always draw my vectors tail to head. So I put the tail of the blue vector onto the head of the first, kind of like I'm doing a visual representation of a story. First, they did the red line, and then they did the blue line, and I kind of just put them in chronological order. Okay, everyone kind of following on that? Okay, so what the question wants to know is, what's the displacement from the starting position? So basically, how big is this part? Okay, this would be the displacement from initial position to final position. Okay, so if the whole blue line is 3.25 meters, and that's 0.75 meters, can I figure out how big this is? Right? Could I say, all right, I'm going to make to the right positive and to the left negative, and just say this? Okay, and just add those two together. Say, okay, positive 0.75 plus negative 3.25. Would that get me the correct answer? What do you think? Is that essentially what I'm doing here? Like this line here, the whole blue line is 3.25 meters, but I only need to know this much of it. That would be 3.25 minus that much, right? Okay, so if I do that, then I should end up with 2, right? No, sorry, 2.5. I'll end up with negative 2.5 meters, if my mental math is okay. Agreed? And do they end up 2.5 meters left of where they started? Sorry, because I can't do math. It's 2.75, not 2.5. Sorry guys, I am still in summer mode and I'm not doing my math right. I'll probably just put the calculator up there. Okay, so let's do this. Oh, it's because I wrote it wrong. Nobody told me I wrote 3.25. I'm supposed to be, I did the math right. I just wrote the question. Okay. That's supposed to be 3.5. Okay, so if we do that, okay, then we're going to get 2.75 meters. Okay, it'll be to the left. Okay, everybody all right with that? Hey guys, if I make a mistake, because it happens all the time, okay, point it out. You're not going to embarrass me. Okay, it's more embarrassing if that happens and I figure it out for myself. Tell me when I screw up. Okay. All right. Let's have you try number 3. Okay, so just if you're trying to visualize what this one looks like, which is a good exercise in physics all the time, is to visualize something. Okay, a bricklayer is going to go back and forth with a trowel, kind of like this. Okay, so they just have like cement and they're just pushing it back and forth with a flat kind of tool. Okay, and so they're saying they start here and they're just going back and forth. Okay, all right, give you a couple minutes there on number 3 and then we'll have a look at that. Okay, so let's have a look at number 3 here. Now, number 3, you can probably just figure out in your head how to do it, okay, for the most part, but we kind of also want to look at what a visual representation of that is going to look like. Okay, so here's our starting position, right? And then the person goes back and forth 1.70 meters 4 times. So basically, they just keep doing this. Okay, if they do that, where do they end up? If they go out and back, they end up back where they started, right at the initial position. That's why our total displacement ends up being 0. You can go back and forth until you wear the tool out, but if you end up back where you started, you have not displaced the trowel at all. Okay, but in terms of total distance, well, that's 1.7 plus 1.7 plus 1.7 plus 1.7. Okay, well, if you multiply 1.7 by 4, I'm pretty sure you get 6.8 meters. Okay, the question's a little misleading. The first time I did that, I went out and back 4 times. I got 13.6 because I did this. I said out and back was 1. Out and back was 2, out and back was 3, okay, because I misread the question. So sometimes questions are like in this thing that we get them from a little bit poorly worded. Okay, did anyone else do that? Say out and back 4 times? Yeah, like it's totally a logical assumption to make. Okay, okay. Any questions on those 3? All right, I would like you guys to try right now 4, 5, and 6, please. Okay, we'll do 4, and then I'll give you some more time. But 4, 5, and 6 are the ones I would like you to do. I'll move this out of the way. So, who do you draw first? If you're going to draw that seating plan, which person do you put on your paper first? Everything starts with Dolores. I can't put Chad on the paper until I have Dolores there as what we call a reference point. It says Chad is 2 meters to the left of Dolores. Okay? So Dolores acts as the reference point for the whole question. Okay? So I put like Dolores here, and then I go 2 meters to the left, okay? And I put Chad there. Okay, and then Ed is 4.5 meters right of Chad, which means he's 2.5 meters to the right of Dolores. That would be 4.5 meters to the right of Chad. Okay, and then Greg is 7.5 meters left of Chad. Okay, so that means he's 3. Yeah, so he's way out here. So this would be Greg. Okay, and Hannah is 1 meter right of Ed. Right, so your seating plan should probably look like that. Okay, part E. What's the displacement of a teacher who walks from Greg to Hannah? Okay, well, 7.5 meters, 9.5 meters, 12 meters, 13 meters, 13 meters. Right. Okay, they did ask for a displacement. That is a vector quantity and does require a vector on it. Okay, how many people have done number 5? Okay, anybody want a little bit more time on 5? Okay, let's have a look at 5. Okay, so 5, kind of the first thing you should probably do is write down your givens. They tell me the displacement, so I know what D is. Okay, it's 50.0 kilometers west. They want to know his final position, so I'm looking for PF, and I have the initial position, PI. Okay, 5.0 kilometers east. Okay, do I have a formula that has those 2 things in it? Yep. Okay, be this one, right? D equals PF minus PI. Only thing I have to be aware of is that I have east and west. So one of them needs to be negative. Yeah, we usually make west negative just because of an XY plot. The left side is always negative. That's where west would be, right? So east is usually positive, west is usually negative. Okay, so I'm just going to manipulate this equation for final position by adding the initial position over to the other side. Okay, so D plus PI should give me PF. That will be negative 50, okay, plus 5. Okay, everybody with me there? Okay, so if I have negative 50 plus 5, then his initial position must have been negative 45 kilometers, or 45 kilometers. Hang on, what did I mess up here? Oh no, yeah, his final position, sorry, is negative 45 kilometers, or 45 kilometers west, right? He went 50 kilometers west. He was 5 kilometers east of something when he started, okay? He's got to be 45 kilometers west of that something now.
When doing the east and west things, do you put a bracket around it and final answer?
You can, or you can just write W. The only time it gets confusing is in Unit 2 when we're using N for newtons, and we could have newtons and north, right? So it's kind of important to keep them separate then. I just out of habit put brackets around them. But if you want to write the word west, that's also fine. Okay, I'll give you guys a few more minutes on number 6 there. So the key part of this that oftentimes people forget is that this ball covers the 3 meter distance twice, right? First, the ball starts with the standing 3 meters apart. The child on the right, this person, tosses the ball to the child on the left. So the ball actually does this. It goes to here, okay? And then it goes all the way out to here. A lot of people just do 5 plus 3 and they're like, I'm done. Okay, that's how far I went. But they forget that the ball started here. This was the initial position of the ball. Okay, so the actual distance that the ball travels, it's going to go, the displacement obviously is just from here to here. Okay, it's just 5 meters to the right because it started here. But the total distance it travels is 3 plus 8, okay, for a total of 11 meters. Okay, just little things. We want to make sure that you're kind of building that skill or practicing that skill up. I got to read questions carefully. Drawing diagrams is super important. Okay, those kind of things, just so that you get all of the little minutia that can be in a question. Okay, so using V equals D over T, because we're going to be using this quite a bit. Okay, obviously you did this in Science 10, okay, but we don't want to see any of this. Okay, like this is over now. You can't use triangles anymore, okay, because they're not going to work for basically 95% of the formulas you're going to use in this course. Okay, so we got to make sure we're doing algebra correctly. Okay, if I wanted to manipulate this formula to solve for t, what would I do? Right, first I would move t out of here. It's on the bottom. I can't solve for it if it's on the bottom. I'll be solving for 1 over t. Okay, so I would want to, move, okay, t, come on, really? You can play that game. Okay, over to here, and then I would move v over to here, okay? Now, when I'm doing that, I'm dividing meters by meters per second. The meters will cancel, and I'll be left with seconds, okay? That's probably the trickiest of the manipulations, okay? Now, obviously, if I wanted to solve for d, it would just be a matter of multiplying t over to this side, okay? Now I'm multiplying seconds by meters per second. The seconds will cancel. I'll be left with meters, okay? You guys have done this before, so that's just kind of a quick review there. Okay. Let's just have you quickly do that one. Okay, that should be pretty simple. Okay, just a v equals d over t question, and we'll go through it. There's a couple more I'm going to want to go over today. Okay. Okay, well, let's have a look at this one. So they're telling us the average speed of this Falcon is 67 meters per second. So they're giving me v. Okay, and they're wanting to know how long it takes. How long is always time. Okay, along a 150 meter path. Okay, vector or scalar? Do we we get any directions? Not specifically. Down would be implied because it is saying dive, but okay, we can't go with things that are not explicitly stated here. Okay, so we got a speed, we've got a distance, we're looking for a time. Okay, we've got this formula that we can use, v equals d over t. We're just looking for t, so it's the manipulation we just talked about. Multiply both sides by t, divide both sides by v. Okay, and we'll have 150 divided by 67. Should take it 2.2 seconds. Okay, ringing a bell from last year? Okay, I want you to try that one. Kind of a two-part question. See if you remember doing two-part questions from last year. Okay, so with this question, we kind of have to remember something that kind of goes along with this formula. Okay? It's not always specifically written in here, but it also technically means this, right? Average speed is total distance divided by total time. Okay, I mean it's implied, right? But it's also true. If we're doing like that hot question we did a minute ago, we were using the average velocity, it specifically said that, okay, over the total distance of 150 meters, and we found the total time. But this also works when we're talking about a situation that has more than one part to it. Okay? In part one, this bus travels 11,000 meters. Okay, why did I change it to meters? What was my speed given to me in? Meters per second. My units have to match. You can't divide kilometers by meters per second. That's apples and oranges. Okay, so just kind of in my head quickly multiplying by 1,000, getting that in meters. Okay, and I know that that had an average speed of 21 meters per second. In the second part of the trip, okay, because of construction or something, okay, it has to go a lot slower, and it only goes 1 kilometer. So now my distance is only 1,000 meters, and it does that at a speed of 4.2 meters per second. Okay. If I'm going to get the average speed over the entire trip, I am going to need the total distance and the total time. Can I get the total distance right now? I went 11,000 meters in part one. I went 1,000 meters in part two. How far did I go? 12,000 meters. Yeah, okay, so that's easy enough. I just add those two up. Okay, that would be my total distance. What I don't have is times anywhere. Can I find them? Yeah, just have to do this in each part, right? I have enough information to get the time for each one of those parts. So I would go 11,000 divided by 21. Okay, so that first part's going to take 523.81 seconds. By the way, I'm rounding off when I write on the board. I'm keeping all the decimals in my calculator, as you should. Okay. And then for this part here, okay, we're going to do the same thing. T equals d over v, so 1,000 divided by 4.2. Okay, so that's 238.10. Okay, can I get the total time now? Just have to add those two numbers together. Okay, so my total time is 761.9 seconds. Okay, so now I I just divide those two numbers, right? Okay, so to two significant digits, I've got 16 meters per second. Okay, does that ring a bell from last year? I know if you were in my science 10 class, we did a whole bunch like that. Okay, anytime you have a two-part question, that's how you have to treat it. Okay, whether it's scalar or vector. Okay, the only thing that changes if it's vector is now you got to take into account if this was north and that was south. We're not adding, we're subtracting. Yeah, I mean, it doesn't really change it. You just have to remember that when it's vectors, you have to keep that in mind. Okay. All right, everybody okay with that one? Okay, I want you to try that one. This is more just about a units trick than anything else. Okay, just make sure you're looking at the units. You do have to do a unit conversion here so that your units match. So what's the unit we have to change? Minutes, yeah. We need it in seconds because our speeds were both given to us in meters per second. So all we have to do is make sure our units always match, okay? Simple conversion, we just have to multiply 12 by 60. All right, so we now know that's gonna be 720 seconds. All right, so we can go tortoise. Okay, and sloth. Okay, this is not a race anyone wants to watch. Okay, so it would be really, really boring. So our time would be 720 seconds. Okay, for the tortoise, the speed is 0.076 meters per second. For the sloth, same time, 720 seconds. Okay, but the speed for the sloth is 0.037 meters per second. Okay, so let's just find the distance that each one travels. Okay, so D, if we're manipulating that formula, V equals D over T, we're just multiplying both sides by T. So we have 720 times 0.076. Okay, so the tortoise is going to go 54.72 meters. Okay, same thing here. D is going to be 720 times 0.037. Okay, so we got 26.64. Okay, meters there, and then it just wants to know how much further, so those two numbers need to be subtracted. Yeah. All right, so you just take your 54.72 and subtract the 26, okay, and you're going to get 28 meters, okay, as the difference in travel. Okay, everybody all right with that one? Right. So, I mean, you haven't had like any really long stories to read yet, okay, but everyone's got some little bit of, you know, trickery or minutia that you have to watch out for, okay? It's just a matter of awareness, really, when you're reading questions. Okay, so this one here, we don't need to draw the position versus time graph for this one, okay? Just want you to try this, and we'll probably finish off with this question. I would think the answer is here, okay, 34 kilometers per hour north, okay? But this is a three-part trip. So like the bus question, part one, part two, part three, and then have some totals and see if you can work your way to that final average velocity, or sorry, the velocity for the last segment. You're actually given the total distance and the average velocity as part of your givens. Okay, so I'll give you guys a few minutes there. Okay, get your givens written down. I'll write mine in about 2 minutes, and you can match them up and then see if you can get it from there. All right, so givens are going to look like this, right? We're going to have, okay, in part one, okay, the trip moves at 25 kilometers per hour north for the first 15 kilometers. Okay, so V with the arrow over top is 25 kilometers per hour north Okay, and D with the arrow over top is 15 kilometers north. Now, they never specify that the 15 kilometers is north, but it has to be because they told me the velocity was north, right? They have to both match. Okay, part 2. Okay, 62 kilometers per hour due north. Okay, for 32 kilometers. Okay, with what velocity does the car travel for the last 13 kilometers? Okay, so part 3. Okay, we know that. Now, here's the thing. This question does give us the totals. It says that it's a 60-kilometer trip. Okay, and the average velocity is 40 kilometers per hour. Okay, that's all my givens. Do I need to convert into units here? Nope. It never specifies what units I need. I've got kilometers per hour, so my time ends up in hours. It doesn't say it has to be in anything, so I'll just leave it that way. Why do more work? Okay, be like mediocrities. Good enough. Okay, we don't need to do anything extra and turn it into seconds or anything like that. Okay, so what do I not have for any of the parts, but I can calculate? Time, yeah, and I'm gonna need that. Okay, so I need to know how long this part takes. Okay, so basically I'm gonna do this calculation at least 3 times. Okay, so T equals D over V for part 1, so that's gonna be 25 divided by 15. Okay, so that part, whoops, sorry, wrong way, backwards. Okay, 15 divided by 25, D over V. Okay, so that one's gonna be 0.6, so that's gonna take 0.6 hours. Okay, same thing for this one. Okay, time is gonna be D over V. This time we'll do it in the right order. Okay, 32 divided by 62. Okay, so that one's going to take 0.516 hours. Can't do it for part 3 because I don't know everything yet. Okay, but I can find out what the total is. Okay, same calculation, D over V. All right, so I'll take my 60 kilometers per hour and my 40 kilometers. Okay, so 60 kilometers, D over V divided by 40. Okay, so 1.5 hours is the total time. Okay, so I know a 3-part trip takes 1.5 hours. I know how long 2 of the 3 trips take. Can I find out how long I spend on part 3? I just have to subtract, right? Okay, so the time for this one is just going to be 1.5 minus the sum of these 2 numbers here. So minus, okay, that one, and minus that one. Okay, so there's what's left for time, 0.3838 hours. Can I find the time or the average velocity for the last part now? Okay, is it like a lot of like busy work to get to that point? It is, right? A lot of questions are like that. You have to do a lot of little steps to get something you need to do the last most important step. Okay, and that was the case here. So we just take our 13 kilometers, okay, we divide it by the time, that was that number there, okay, and we get that last part was 34 kilometers per hour. Okay, we'll leave it there. Plan for next week is that we will probably start talking about position versus time graphs. Okay, do our first lab, probably on Thursday, okay, of next week. Good work today, guys.